Hello and welcome to NUMOA's Materials Management 101, Types of Solid Waste Facilities.
So with that, let's go ahead and get started. We have two great presenters with us today and with lots of expertise. And they are Amanda Wade from TRC and Jamie Garvin of ecomaine. So before we jump in, Amanda, why don't you give us a little more background on your experience?
Sure. So I've been doing solid waste work in New England, northern New England especially, for about 24 years. I started my career with the Maine DEP actually as a solid waste engineer in the solid waste engineering unit. Was there for about 15 years. And since then, I've been consulting and helping facilities to stay in compliance with the regulations that I used to impose on them. I am the current president of the Northern New England chapter of SWANA and am vice chair of the EBC Solid Waste Management Planning Committee.
Great, thank you. And Jamie, how about your experience?
Thanks, John and Amanda. Pleasure to be with you all today. My name is Jamie Garvin. I'm the Director of Communications and Public Affairs at ecomaine. We are Maine's leader in sustainable waste management, and we'll talk a little bit more as we go through the presentation about some of the facilities that we operate. I'm a past board member of the organization. I served for 6 years on the board when I was in an elected municipal official role in the town that I live in, which is a member-owner community of the municipally owned nonprofit that is ecomaine. And my journey in waste management and sustainable waste management goes back to days serving on my town's recycling committee way back before I got into elected politics as well. So happy to be here. Looking forward to the information that we're going to share today, and turn it back over to John and Amanda.
All right. Thank you, Jamie. All right. Well, why don't the presentations probably should last about 40 minutes or so. And then we'll have questions and answers after that. So why don't we dive right in, because I'm sure there's a ton to cover.
Sure. And can you see that okay?
Yes, looks good, Amanda.
Excellent. So as John mentioned, this presentation really just gets into the types of solid waste facilities that are out there and what options exist currently for our materials management. And so with that, I thought we would start kind of taking a look first at solid waste management over time, starting with our original dumps that we all had in our towns back in the 60s and 70s, all the way up through the development of transfer stations, how our waste haulers work, our landfill development, incinerators and waste to energy, compost facilities, anaerobic digesters, recycling and processing facilities, and what's next. This is just a diagram to show you what EPA's current waste management hierarchy looks like. Again, it supports all of the infrastructure we just talked about and really does put emphasis on source reduction, recycling, composting, with disposal and treatment at the bottom. So our landfills would be, a least desirable of all of the waste management in the hierarchy. This was developed by EPA early on and has been adapted by many states, and it looks slightly different depending on what state you're from, but ultimately kind of mimics this layout. So I thought I'd take a look just briefly, and I'm not going to read all of this to you guys because it's kind of dry, but just kind of going down through the regulations and guidance that were issued from the 1950s forward. It does show how each of our management infrastructure was formulated, how they were developed, when they were developed. You'll really see closely how, as EPA supported certain things, that you'll start to see development of those processes in real life. And so you'll see really there wasn't a lot done until you get into the 60s. As most of you know, EPA wasn't even created until the 1970s. And then we started to see, RCRA, which really began the ending of our open dumps in 1976. And then we started to see that advocacy towards recycling and diversion in the late 80s. And then as we were, again, getting into things like incineration, we're starting to see that MSW power as renewable fuel and the institution of back technology for emissions. And then 1991, for all of us that do landfill work, that was the big year for when EPA finalized those Subtitle D regulations. They gave us those minimum requirements for landfill design, and you'll see that states at that time started to adopt regulations that either mimicked EPA or were slightly more stringent than EPA. And that really did lead to the closure of the majority of the unsecure landfills at that time. So I know in Maine, for example, we closed over 400 sites in the early to mid 90s. And then you see again, as we head into the 90s, a bigger push towards waste prevention and recycling, and what's interesting here is that, it's both parties. First with President Bush and then President Clinton, really pushing some recycling and getting some diversion out there. In 96, EPA set those recycling goals of 35%. Which were at the time, that was a big push. We've now been increased to 50% by 2030, which is wonderful. So we're just seeing a continuation here of really diversion goals. So food recovery, recycling goals, and we're seeing, EPR on the state levels now really hitting the mainstream. And so if you really take a look at all of these laws and regulations, you'll see how that interacts with how we developed our solid waste management infrastructure over time. And this chart really shows that. So as I mentioned, in the 1960s, we really started taking a look. 70s and 80s, you're starting to see regulation come in. In the 70s, we're seeing a support for incineration, many of those combustion facilities coming online in the early 80s as the technology was there. And the closure of, the old dumps and landfills. Unfortunately, we've been quite stagnant. You can see over time, this does end in 2018. We were seeing an uptake here at the end of food management infrastructure, which is wonderful. And we're seeing more and more of that with the organics diversion. But you can see that there really has been some stagnation in how our wastes have been managed and by what types of facilities they are managed. So those original dumps, those were all, unlined disposal sites. Many municipalities had them. They were open, they weren't cited. Oftentimes it was, well, there's a gravel pit, let's fill it in. Oh, here's a stream base, let's put, some waste in here. We want to use it for something in the future. And it was the area that most of the local residents knew that they could go to take their trash. It was not covered and compacted. It was often burned in open pits to reduce the volume to make that area last longer. Liquids were not managed at all. You had no leachate collection, you had no diversion of stormwater. But as I mentioned, most of those were closed in the late 80s and early 90s with those establishments of the solid waste regulations. With the closure of the dumps, we started to get into transfer stations. So many of them they are all permitted by state regulatory agencies, and many of them were cited on the facilities that the town knew as the dump. So I'm sure many of you have gone to your local transfer station and you've looked out back and there's a green mound. That's because historically there wasn't a dump there, and all the residents knew that's where they could bring their waste, and so the transfer station was cited there as well. Regulations around transfer stations are much more restrictive than they were in the time of the open dump. Wastes are stored on constructed pads. That is to protect the groundwater and to keep the waste out of contact with the water, but also to keep the ground out of contact with the waste. It makes for easier cleanup and maintenance and making sure you can get all the waste removed for transfer. Wastes are stored separately with clearly marked areas so that you can limit contamination of your recyclables, for example. You want to keep your metals in the metal pile, for example, and your wood demo in the demo pile. And then as you go into a building, you'll have your recycling materials, your MSW, and things like that. So they are managed to ensure regular, complete removal. Transfer stations are not disposal facilities. They have a timeline in which they're allowed to store materials. Putrescible wastes like organic materials, food wastes are stored under cover. That is to limit leachate production. We want to really make sure we're not allowing that rainwater or the stormwater to get into the material. That can add to a little bit more rapid decomposition, definitely can lead to odors, and just management of leachate on the site. We want to keep our stormwater at those facilities clean and manage as little leachate as possible. And they are designed to allow for safe access by waste haulers and residents. And that can be tricky when you have that many people coming in and out of one facility. So some of the challenges around our transfer station is providing adequate storage for the users and being able to somewhat predict growth within your municipality, as well as what materials may we see in the future that need to be separated. So you may see newly regulated materials or new waste streams, like e-waste, for example, where you want to keep it separate, needs to be handled separately, or a new material that may have a new recycling goal that you want to keep separate. Early on, we would have very basic, paper separation, plastic separation, glass separation. And now we're seeing things like organics and compost areas being brought in, or leaf and yard waste piles and demo piles. So really being able to kind of predict that as a challenge for these facilities with a limited footprint. And as I mentioned, management, obviously, of household hazardous waste and e-waste is tricky. Those materials need to be typically behind a gated area, locked in a building, so that you're limiting your access in and out by the general public. Stormwater management and diversion, again, is key. You want to make sure you're handling as little amount of water as possible into your waste. Water can certainly increase tipping fees as well for your materials leaving the site. And then management of things like bargain barns. We do have facilities that will have small buildings or drop-off areas for goods that still have a benefit to the public. And usually this is offered as a free service where you can bring a material in, will go into this little structure, and then somebody else can come in and look through the pile or the area and determine whether it's something that they'd like to take home with them. That is tricky for some folks as well, because you certainly want to make sure that you're not putting materials in there that are truly waste, and that sometimes residents are just trying to avoid paying a disposal fee, for example, for a couch, when really there's no life left in that couch, for example. So having people there to kind of manage that can be tricky. Odors can certainly be tricky from organic materials, especially in summer months. I know up here in northern New England, we have seafood season where the tourists are here, and if you have a lot of materials coming in that contain seafood waste, that can certainly be odorous on certain weekends. So managing odors can be tricky, and again, traffic flow can be problematic. And I know Jamie wanted to mention something that he's seen in the past.
Yeah,
in regards
thanks,
to that.
Amanda. In our own town, in our transfer station, we tragically had an accident about 10 years ago where a vehicle struck a user, and we unfortunately had a fatality. You've often got families that might be making their weekly trip to the transfer station with young children running around, or just inexperienced or inattentive drivers and things like that. So these are industrial facilities, but that are accessed by the general public, who might not be as familiar with some of the safety protocols that more experienced waste management operators are. So by opening and exposing the facility to the public, there's a lot of inherent risk that comes with that, and a lot of education that's necessary to make sure the folks are in compliance with the safety protocols.
Sure. And, also our staff and the staff of those that work in those facilities, they have safety gear requirements, for example. They're going to wear their vests so traffic can see them, so the haulers know where they are coming in and out. They're going to have steel-toed boots on to make sure that they're not stepping on anything, or if they do, it doesn't damage their foot. The general public is not doing that. Saturday morning in Maine, you're going to go to any transfer station, you're going to be in flip-flops and shorts. Certainly not going to be high-vis vests. And so, those types of things are definitely challenges for these facilities, because there are so many members of the public in and out of them. So then we also have our waste haulers. And waste haulers can collect a variety of waste materials. So it can be strict MSW or recyclables from residents. That's typically a door-to-door pickup or business-to-business pickup, depending on the contracts and who they're servicing. Can be both private or public. I know the area that I'm from, each individual resident hires a private hauler to come and get their material. Other areas we have, municipalities that will hire somebody to come around, or they'll have their own public works crews that can go around to pick up waste material. So it's a mixture of the two, depending on where you are and what region you're in. As I mentioned, they may focus on single stream material type, and we may see more and more of this as we continue to have waste diversion. So you may see, waste pickup of organics, for example, if they have a contract with an anaerobic digester or compost facility, where you may just see the food waste truck coming through your neighborhood, picking up all of your food waste to take off, and then you may have a second day where you're having your single stream recycling picked up, or another day for your MSW. And so there's a variety of waste haul vehicle types, as well as licenses that are required for those. And they do require licensing, depending on the number of houses or businesses that they pick up from. It could be a slightly different licensing requirement, but they are required to be licensed. Not anybody can just go around and pick up everybody's trash. And some waste may require documentation or manifesting of those materials, similar to our haz waste requirements, but not quite as stringent. And in that material, you'll see that the type of material has to be specified, where it originated from, and where that receiving disposal facility is. And again, that's just to ensure that any material that slightly more regulated is closely tracked. And so there are certainly paperwork around all of this. Our challenges for waste haulers, very similar to transfer stations. Liquid management is big. They're not going to want to pick up from a dumpster that's been open, for example, during a rain event, because they're going to be transferring that liquid into the back of their truck. And I'm sure many of you over the years have followed behind a waste truck that had a stream kind of coming out the back end. That's something that they need to avoid as much as possible. So liquid management is key for them. Waste and recyclable separation is also key. You'll see some of the newer trucks will have multiple compartments, depending on what types of materials they're picking up, which allows them for MSW pickup and recyclable pickup on the same day, for example. Safety of employees. Safety employees is big. Most of our waste haul companies still employ workers who hang kind of on the back of the truck so that they can quickly get off, load the waste into the back of the truck, and move forward. And then record keeping, again, is key, making sure all the documentation of where that material went, how much material came in, where it came from. We are seeing some innovations, though. We are seeing some automated equipment. There are some that have arms that will come off the side of the truck and dump the waste into it. Again, it's for the safety of their folks, that they're not now required to run across the street, for example, to pick up the waste. We're seeing more and more of that. We're also seeing gas-powered, like natural gas-powered vehicles. Landfill gas-powered vehicles are also something that we're starting to see in larger municipalities where their landfill may have gas collection, and they may be making like a liquefied natural gas type of product. So that kind of gets into our current landfills. And as I mentioned, those are very different from the dumps of yesteryear. And I would challenge each of you when referring to them to specifically call them landfills and not dumps, because we did have open dumps for a long time. Our landfills are permitted by state regulatory agencies, and they are designed for safe and environmentally secure disposal of our solid waste. They have a lot of requirements around the type of liner systems that are employed, how those liner systems are constructed, and how things like their leachate or their gas are managed within the landfill, how it is collected, what their waste placement practices are. And that is oftentimes to reduce leachate production, to make sure that they're setting themselves up for adequate gas collection and leachate collection, as well as making sure they're maintaining a stable waste placement. So you'll see, for example, if we have a landfill that accepts, in Maine right now, biosolids is a big deal. So if you're accepting a lot of biosolids, it's a very wet material. And so they'll have waste placement practices that require certain mixing protocol, certain placement in areas to allow for dewatering or compaction so that they can continue to be stable and their equipment can continue to operate on it. And then all landfills have cover system placement requirements, and that is, from daily cover, which is required at the end of each day. A 6-inch layer of soils or alternate daily covers can be certain waste materials that may not be odorous or have a lot of litter in them, for example. You may see things like contaminated soils used there. Sometimes ash can be used as an alternate daily cover. And then you'll have an intermediate cover. That material is placed on side slopes that are at their 3-to-1 or at their final slope, or an area where you may be off of the landfill for 6 months or more. So if you're staging your operations and moving across the landfill, you may be required to place intermediate cover. Again, it's to limit leachate production, make sure you're limiting your odors, your vectors, and things like that. And then final cover system placement is required on all landfills once you've been off of it. Most regulations require within a year of the last amount of waste placement. And so you're really looking to start that initial design of your landfill closure, usually a year or two prior to reaching your capacity, because you're going to start, getting your design approved by DEP, getting your contractor on board to get out there and do your closure work as soon as possible. Landfills also have an extensive environmental monitoring network. They're all cited now. to make sure that they're limiting impacts on groundwater. So they're not going to be on things like a sand and gravel aquifer. You're going to have separation to bedrock, things like that. So you'll see that each of these landfills is monitored. You know, their groundwater is monitored, their surface water is monitored, landfill gas is monitored, depending on the type of landfill you may have and whether or not it's one that, you know, actively produces methane, for example. And in some cases, you may even have ambient air monitoring. And that could be if you have a facility, for example, that produces a lot of hydrogen sulfide because of the wastes that they accept. So this is just an example of one of the sites we work with. And you can see, you know, a couple of up gradient monitoring wells, a whole slew of down gradient monitoring wells, with some surface water locations here and here, as well as some leachate collection monitoring points. So we'll take samples of that material as well so that we can compare that against anything we may see in the groundwater, if anything at all. And our monitoring well casings kind of look like this. I'm sure you've seen them around most sites, not just landfills, but anywhere that you're looking at groundwater. Some landfills may be limited to single waste types. We refer to those as monofills. So Jamie will talk a little bit more about this as he's talking about how they handle their materials at ecomaine, but incinerators, for example, do produce ash. And so you may have some landfills that are strictly ash fills. You may have industrial landfills. We have had a few of these in Maine where we had paper mill landfills, for example, where their primary waste stream was sludge. They may have a little bit of ash from their facility as well, but for the most part, they were sludge. And then things like construction and demolition debris may be, isolated in a single landfill instead of having it mixed with other things like MSW. Some of the challenges around landfills, obviously liquids management is key. We are collecting any and all liquid that falls on the waste. It is leachate by definition. It must be collected and treated. So you really want to minimize production of that because that is a cost to your facility, as well as, with an increase of leachate production comes an increased risk of release. So you want to minimize that as much as possible. Even with a great liner system, you can have releases, over land, for example, through access road maintenance, things like that. And so the least amount of leachate you can produce, the better for your facility. Odors, certainly an issue at landfills, especially if you have neighbors that are relatively close to you. It's nearly impossible to have a no odor landfill, but you want to make sure you're limiting your odor production to the greatest extent possible. You do not want to be a nuisance in your area. Vectors, so things like rats, seagulls, any type of animal that could be on your site, you really want to limit that as well. And then public relations and just being a good neighbor. Those are challenges. Really making sure you're keeping that door open to discussions with your residents and your neighbors, understanding what's important to them, letting them know how you're doing things at the landfill. Keep them informed of things that may be going on in the future. If you're going to be, excavating in an area of your landfill, for example, that may increase odors for a day, let them know that. Let them know that you expect it to be short term. This is how we're managing it, but we just wanted to, fill everybody in. Good relations can go a long way in working in these types of environments. And then again, record keeping. Landfills really do have an indeterminate amount of time that they have to keep records of all of the materials they bring in, because once it's disposed of in the landfill, it's not going anywhere. So that can certainly be a daunting task for some of these facilities. But again, we're seeing innovations. We have gas to energy projects going on at many facilities. We're seeing post-closure reuse of landfills once they are closed, either with solar development or parks and dog parks for public access. There are ways that we can reuse these sites into the future to make them assets again to the neighborhood. Now I'll turn it over to Jamie so he can talk about incinerators.
Thanks, Amanda. As I mentioned, ecomaine is a leader in sustainable waste management, and we do so through 3 different facilities. So I'll talk through a couple of those here. And the first is our waste to energy incinerator plant. So much like landfills and other aspects of the waste management ecosystem, we are permitted by state regulatory agencies. We're held to very strict and stringent monitoring to make sure that we're meeting all of the meeting or exceeding all of the thresholds for the safe and environmentally sound processing of waste. We are regulated by both the US EPA as well as in our state, the Department of Environmental Protection. We're also ISO certified for our environmental management system. So that's a designation from the International Organization for Standards that some facilities look to achieve. as a statement and testament to their protocols and procedures. At our incinerator, we're producing electricity using the MSW as the fuel for our mass burn facility. So we're processing about 180,000 tons of municipal solid waste through our facility, and through our process of burning and treating that material, we're producing 14 megawatts of what is renewable electricity after the EPA in the 90s designated MSW as a renewable fuel source. The big benefit to that is reducing down the volume of the waste that then goes on to landfill, or as Amanda said, in our case, ashfill storage, by a significant amount. And I'll talk about that more in just a second. So here's just a little bit of a schematic overview of what our facility looks like. So from moving from left to right across the diagram, we have a tipping hall where haulers will bring and dump the material onto our tipping floor. That then gets pushed into a bunker. The bunker can store about 40,000, is about a 40,000 square foot space that can store the waste material, where it's then lifted up by a huge mechanical crane and dropped into one of our 2 boiler systems. That boiler system has a series of sort of shelving where the material is being shifted down and burned with pipes going up the side of the boilers. The process is basically as old as the Industrial Revolution, where we're creating steam energy. So the fuel source is the MSW. It heats the water in the pipes. The pipes create steam. The steam then turns a turbine. The turbine powers a generator that produces the electricity. So no different than any other sort of steam engine plant of any kind. It's just that we're using household trash as the fuel source instead of some fossil fuel or other material. We do have rigorous pollution control systems, as you see indicated in the red circle here, where we're removing nitrogen oxide, removing mercury and dioxins. We're injecting urea and carbon and other elements into the process, such that as the flow goes through that flue gas portion of the plant, we're removing all the particulate matter. In our case, we're using electrostatic precipitators. Some other incinerators use what's known as a baghouse filtration method. But in any case, all of that is designed to make sure that we're not creating a bigger problem through dangerous and harmful byproduct of the burn process. What results in coming out of our stack at the end of the process is largely vapor, 96% water vapor that's coming out of our stack. So on any given day, if you were to look at our facility, you typically wouldn't even see any evidence of anything coming out of there. It's only when the atmospheric conditions are such that you see sort of condensing steam going into the atmosphere. But we'll often have people driving by the facility thinking that it's smoke coming out, but it's in fact largely water vapor. The benefit to all of this process is that we're reducing down that 180,000 tons of MSW that I mentioned earlier by about 90%. So we're taking up a significantly less amount of space when we ship the ash byproduct a couple of miles down the road to our ashfill facility, where it is stored in the same way that Amanda described for other landfills, with an alternative daily cover and then capping and things like that. So we have a much longer shelf life for that precious space at the landfill versus what would fill up at 100% volume of the MSW. The other thing is that it's an inert ash when it goes there. So unlike landfills that have the issue of methane off-gassing and things like that, the ash produces a negligible is negligible in its production of methane. So where we now know landfills to be the number 3 contributor to greenhouse gas emissions, methane in particular, behind oil and gas production and agriculture. By ash filling from a waste to energy process, we basically eliminated that out of the equation. So Amanda, you want to go to the next one? Some of the challenges in operating a facility like this, we do have twice yearly planned maintenance, where we will shut down the boilers one at a time. We have a dual boiler system in our location, but we'll shut them down one at a time for regularly planned maintenance and upgrades and things like that. There also are unplanned shutdowns when there's equipment malfunctions of that sort. We had a turbine failure a couple of years ago that while we were still able to burn in the boilers, we weren't producing electricity. So that was, disadvantageous to the organization. So there's, all of the associated issues with that, from running a complex power plant as compared to sort of a static landfill. The other thing is regulatory updates. So Amanda referenced before the BACT rules. We're currently looking at a rewriting of the MACT rules, which is the maximum achievable control technology standards. So I said that we use an electrostatic plate system, electrostatic precipitator system for managing our pollution controls. Other facilities use what's called a bag house. The EPA is currently looking and re-examining their rules and thresholds. Depending on where they go with their ruling, which is expected in later in the fall, early winter, it could have impact on facilities that don't employ a bag house type operation. So, constantly looking at things like that and a litany of other regulatory updates to keep up with the industry. We have, as is, no different from other aspects of the waste ecosystem, a huge problem with contamination, most specifically with waste associated with electronics. So lithium-ion batteries are a huge problem for us right now. We have, extensive fire suppression systems in place and triaging methods to make sure that we don't have a catastrophic event at any of our facilities. But it is something we're seeing on a regular, multiple times a month basis these days at both our waste energy facility as well as our recycling center, which I'll talk about in just a second. But the amount of e-waste material that's coming through, not being disposed of properly, causes significant both facility and personnel risk that's associated with that. The other thing is, the ash that we are sending to disposal. We do, still have a lot of issues with the mitigation things relating to leachate and things like that. So, being able to stabilize that ash, is something that is, a high consideration. And sort of already talked about with the regulatory updates, but the emission standards, which are, constantly changing on us as well. So that's a little bit more, subject to also to, sort of the political winds of change, if you will. So, being able to shift depending on, what type of policy is being pushed down, creates a less stable regulatory environment. So for composting facilities, that is a huge opportunity within the waste stream to remove potentially up to 40% of the typical municipal solid waste stream. Has a major benefit of removing a source of primary source of methane emissions from municipal solid waste. So these are, obviously designed to have a dual benefit of, being a more beneficial use of the material, and also being designed to protect, human health as well. There's multiple different types of organic materials, food waste being, among the largest from the municipal stream, leaf and yard waste, agricultural byproduct, and then biosolids as well. Just, as a tangent, here at ecomaine, we have a cooperative operation with a facility that operates an anaerobic digester, where we're basically collecting the source separated organic food waste and having them take it and transport it to their material. So we're not processing any organics on site ourselves, but instead have sought out strategic partnerships to be able to do that. So we'll talk about anaerobic digestion in just a second, but in terms of aerobic compost, this is a huge opportunity, for managing that material, turning it into a commercial product, right? So lawn and garden use, fill, things like that. It is, still a pretty precise and scientific process, though, of making sure you've got the right mix of materials, making sure that you've got a controlled temperature environment, things like that, and then ensuring that you do have markets and customers for that end product. So, I think on the next slide, we talk about some of the challenges with operating, a facility like that. There is a huge, issue to be mitigated with ruminants and vectors and things like that. It, in some cases, can produce odor. Some cases, it's a very attractive odor, a very, or sort of earthy, rich smell, depending on how well managed the facility is. Liquids and non-compostable contamination are an issue for sure. And then, some other things around record keeping and so on. I think the other thing in terms of, what the future looks like, I think there's a limit to the scalability of these types of facilities too, right? So these are good in sort of, a specific purpose, but don't really have the ability to meet and match the need were we to really scale up the diversion and collection efforts associated with composting and food waste organics diversion that would be necessary to make a real significant impact in the amount of waste that we're producing in our MSW. So I'll hand it back over to Amanda. She can talk a little bit more about the anaerobic digesters. And like I said, we have a partnership with a company called AgriCycle. They're located, at a agricultural site. So they're taking our material and then putting it through their process, which Amanda can describe to you.
So I'm sure you're seeing the theme here. Like all of the other solid waste handling facilities, they do require licensing. They are designed to be protective of human health and the environment. And like composting, they are designed for the collection of organic waste materials. So it's food waste, leaf and yard waste. And as Jamie mentioned, if you can be lucky enough to be co-located on a facility like a farm, also have an animal manure source, and then things like biosolids as well. And so really is for the organic material is, entered into the pit and into the digester. You're producing a biogas that can be used for electricity production, or we're seeing it liquefied in some cases to make fuels. And then, it's sent off. You'll also get a byproduct that can be used for things like animal bedding. So it is, again, operated to be biologically decomposition of waste. Unlike composting, though, this is anaerobically. So you want to really reduce the amount of air that's getting in there so that you can increase the decomposition and the gas production. When you do composting, you want to really minimize the amount of gas production that you're making. You're going to turn your piles. You're going to keep it aerobic. For anaerobic digesters, you're doing just the opposite. Like I said, they can be co-located. We have one in Maine that is like that does partner with ecomaine, and it does produce biogas and digestate. So the digestate can be both a solids and liquid, and we have seen that the solids can be used in things like animal bedding, especially if the facility is capturing the manure again to put back through the process. That is what it happens up in Exeter, and then it will produce a fertilizer product as well with solids and liquids. Again, things that can be challenging for these facilities are waste contamination. So any materials that don't decompose in the anaerobic digester certainly could contaminate your product. So you don't want to be spreading plastics, for example, in your digestate if you're using it for agricultural purposes or for fertilization. If you're fairly rural, things like electrical interconnect can also be tricky for these facilities. If you are producing electricity from the gas, and then just making sure you do have an end use for that digestate. Then I'll turn it back to Jamie for recycling and processing facilities.
Yeah, so like all has been said, we do require licensing for recycling facilities. They're absolutely designed for the benefit of public health and the environment. These are facilities where we're collecting the waste materials for processing, recycling, or reuse. So there's various forms of that. They may be designed for a single material type. We have specific metals recyclers, as an example. Those have sort of been the successors to the typical scrapyard, junkyard type of facilities that existed in the past. We have specific facilities for construction and demo materials. And then there are also single sort recycling facilities for household recycling materials, of which we operate one here at ecomaine. So those are what's known as MRFs. You'll hear the acronym thrown around. Various people have assigned different definitions of that acronym, from materials recovery facility, materials reclamation, materials recycling facility, multi-reuse facility, things like that. Whatever you wanted to describe it as, It's a place where materials are collected, sorted, and prepped for the recycling markets. So they are usually the first step as part of another type of waste management facility like ours here at ecomaine. So we're taking all of the recoverable, recyclable materials, running through a process. Anything that is left over from that is deemed non-recyclable goes into our waste to energy facility. The materials that are most commonly put through a MRF include metals, plastics, paper, and by paper, both mixed paper as well as old corrugated cardboard, things like that. These are, all being separated, sorted, and then baled to be sold on to either direct buyers or brokers that are moving that product along to processors of the material to be turned into other and new materials. Challenges here, like has been stated before, we do see a lot of contamination of non-recyclable materials. Part of that is really due to, I think, some consumer confusion about what is recyclable, what is not. We've almost, in some ways, done too good of a job in educating the public in terms of, really changing their behaviors towards having a recycling first mentality. But the result of that is sometimes, not just sometimes, very oftentimes, materials that wind up at our recycling facility that may seem recyclable, but aren't what we would describe as readily recyclable. So in many cases, those can have a deleterious effect on our processes. When you think of things like plastic bags or stretchy films that might get tangled in the equipment, other things that are labeled as compostable. From some of those, sort of newer materials that are plant-based or things like that aren't actually 1 through 7 plastic. All of those types of things are winding up in our waste stream because people think that they're recyclable. Either they're from greenwash labeling or from wish cycling on the part of the consumer. There is a question on the materials of first in, first out. So you're not necessarily moving the product that you have the best market for or highest demand for, things like that. It's, in a single sort environment, you're sort of taking everything all at once and going through the sort process. There's a lot of variability and in some cases instability in the markets for these products. So most people, I'm sure, have heard about back in 2018, China's national sword policy that was a hugely disruptive event in the industry where they stopped taking the materials from most of the global markets. The domestic market here in North America has largely caught up to that at this point. So from a processing and throughput perspective, things have sort of stabilized and normalized to pre-China national sword policies and conditions. However, it did have a very big disruptive impact to the market. Again, like other parts of the industry, there are changing regulations here. And again, most importantly, from a safety and health perspective, a lot of hazardous materials that come through recycling facilities as well. Again, mostly e-waste, things of that sort.
So we've talked a lot about, where we've come from and where we are now. And so I figured we'd just mention really briefly what's next. So there are some technologies out there that we're seeing that have some promises for us for our waste management. One of them being gasification. Similar to incineration, it converts MSW to energy, but in this case, it actually produces a syngas. Unlike incineration, it's a low oxygen environment, so it's high temperature, low oxygen, and it can produce a syngas and then a byproduct that hopefully would have a beneficial use. And then, Jamie, you were going to mention your plans for your automation.
Yeah, so we're actually in the process of planning for and will in 2025 be building out a new MRF across the street from our existing facility. When our current MRF opened back in the late 80s, early 90s, the equipment then was very state of the art. It is no longer so. In today's world, just like everything else that's being influenced by artificial intelligence, AI, and other ascendant technologies, the ability to use optical scanners and automated sorting has made huge leaps and bounds in this industry, whereby you're employing various sensors or cameras that are in an instant, taking an image of something passing by on a belt and matching that up against a database of millions of other images to know exactly what type of material that is and where it belongs. There are further advancements being made in the the equipment to collect material in a more automated process as well, such that some of the things that we are concerned about today in terms of not readily recyclable materials or things that are causing us issues with clogging up our lines and facilities and tangling up our equipment and things like that. The type of ballistic screening mechanisms that we might employ in our new facility would greatly reduce or eliminate that, such that we can really see some substantial gains in both the efficiency of our throughput, the quality of the material coming out on the back end, and the safety of our valued employees. So,
excellent. So with that, we can take some questions and answers. This is just contact info for both Jamie and I.
Great, thank you both. Wow, that was a very comprehensive overview of our types of solid waste facilities. Tons of information there. And just for those of you listening on, we will be posting their PowerPoint on the NUMOA website under Solid Waste Materials Management Training tab. So you'll be able to see that with all that great detail. Also, a recording will be posted there. So now I invite everyone to, if you have questions along the way, please drop them into the Q&A. Yeah, I think we have enough people that we should do that versus hand raising. If you'd like to explain your question more, just drop that into the chat and we can unmute you. To get us started on questions, let's see. I'll just get going on some here that came up for me. Amanda, you showed us a graph of solid waste generation and disposal endpoints over the last 50, 60 years, maybe more. And it looked like in the very end, there was a bit of an uptick. And it looked like the uptick in disposal amounts corresponded with the uptick in food waste diversion. Is that a data thing, or are we actually generating significantly more MSW in the last 5-10 years?
So we actually are producing more MSW, unfortunately, in recent years than what we had in the past, and lots of reasons for that people have kind of thought of, but overall, we really have become a very disposable society. Many of the products that we buy really are 1 or 2 year products if we're lucky. If you look at things like clothing, for example, with fast fashion, certainly seeing a lot more of those entering the market, therefore entering the waste stream. And so we are seeing a lot of that coming in. And then with COVID, we saw an uptick in waste disposal in general because people were cleaning out their homes. And I think we'll kind of see a little bit of that too as our population continues to age. Many of us older individuals are stuff people. Many of our younger folks are minimalists. And I think as we start seeing people clean out their family homes and things like that, we're going to see kind of an uptake as well of some waste disposal for a little bit. But
interesting. Great. Thanks. Jamie, I have a question for you. In the incinerator, food waste has BTUs in it, obviously, but also has a lot of water. So I'm wondering, from an incinerator point of view, is it good to get the food out and manage it in another way, or is it fine to leave it in?
Great question, John. In addition to all the benefits I mentioned earlier about, converting to a beneficial use of the organic material and reducing the methane gas emissions that result from it, an incinerator operator like ecomaine definitely does not want to have it in there because even though it does have the BTUs that you mentioned, it's incredibly dense, heavy, wet material. And that does not result in a clean and consistent burn for us. So one of the things that claw that I showed in the schematic of the plant does is not only lift the material into the boiler itself, but is also spending a good part of the day basically stirring the pot, right? So if you think about your own fireplace that you might burn in your house, or at a campfire if you go camping or something like that, you need to have the right mix of materials, you need to have the right mix of airflow and all of those kinds of things. And it's really no different in the boilers that we're operating here as part of our waste energy plant. So if we get a load that comes up in that crane and is particularly heavy with dense wet food waste, it just becomes more of a management controls issue, for how that burn gets managed and things like that. We like to see the most consistent and constant burn that we can. We do operate the facility 24/7, 365 days a year to generate those 14 megawatts of electricity. So having a regular and consistent quality of burn is really critical to that.
That's interesting. How incinerators do reduce the methane reductions, because we know even if you have a gas collection system at a landfill, there's going to be a lot of fugitive methane emissions, and the incinerators really take care of that. How is the toxicity of an ash versus an MSW landfill? Is there higher toxicity, or does the burn sometimes reduce toxicity, or how is?
So we're burning in our boilers at up to 2,000 degrees Fahrenheit, which is what's scientifically referred to as a complete burn. So toxicity is virtually eliminated in that process. And like I said, because it's an inert ash, it's not breaking down, it's not causing the same kind of emissions that you would have from traditional landfill breaking down. So it really is a near as ideal solution as we could have, all things considered. Obviously the burn process is putting carbon dioxide back into the atmosphere, but that is like I said, through the pollution controls being mitigated to the highest degree possible. And then the scientific research demonstrates, and a report that was released this spring about how much bigger a contributor landfills are to that methane gas, greenhouse gas effect, that doing whatever we can to avoid that, incinerators become a real, I think, key solution in that equation.
True, that's interesting, because in the more recent decades, incinerators have kind of fallen out of favor, as opposed to landfills. Why do you think that was?
Well, they're quite expensive to build, so they're capital intensive to build as compared to a landfill. I think the other thing is, we're talking to on this call to a group of folks from New England. Many states in New England, when it comes to landfilling, they're not actually seeing that in their backyard, right? So, there are states where material gets loaded up on a train and it's going away, right? So it's sort of out of sight, out of mind. They don't really give it much thought. One of the things we talk about both here at ecomaine and then, in the industry more broadly is, landfilling can only be considered a waste storage solution. It is not a waste management solution. Okay. So once it's at a landfill, it's always going to be at a landfill, and forever will it stay as a landfill material. And there's very little other than, as Amanda described, some solar siting or other recreational use type things that you can do with former landfill type facilities. So, it is at the bottom of the waste hierarchy for a reason. It's the least beneficial, way to handle material. And so we're constantly looking at ways to push things upstream as much as possible. And we, went through all the enumerated different rungs of the waste hierarchy at the beginning of the conversation. So, I'd say, like I said, the biggest barrier is sort of the capital outlay. They do tend to pay for themselves over time through the generation of electricity and revenue generated from, your processing fees and things like that. But to get one off the ground, and in a state like Maine, we currently have a moratorium on any new landfills or waste energy facilities. So depending on the regulatory status and wherever you are, it might not even be an option right now, even if you remove those barriers that I just talked about. So.
Right, and if I can add a little to that, I mean, you mentioned that, a little bit less looked at than landfills. I mean, in New England or really New York North, good luck siting a landfill. I think any new development for solid waste is very difficult right now. Solid waste management in general is a very public topic. Nobody wants to have it in their backyard. And unfortunately, it is less expensive for many municipalities to, as Jamie mentioned, rail that waste out to Wisconsin or to Ohio than it is for them to try to go through the process of siting a new facility, whether that be a landfill or an incinerator. I do think you'll start to see some changes, hopefully here in New England, as our capacity crisis really does come to head. Many of our states don't have enough capacity at all to manage their materials. So Massachusetts, Connecticut, Rhode Island, Vermont has one landfill, New Hampshire has one landfill. Like, we're really getting down to crunch time on how we're going to manage our own material without being a burden on the rest of the country. So I'm hoping we'll see more and more, as the new technologies come up for incineration, or, we can site them in conjunction with landfill type facilities, because, as Jamie mentioned, we do have some byproduct. So we're always going to need some need for a landfilling of the residual from our processing and treatment facilities. But hopefully we can kind of get there internally as we're, developing these new technologies.
Yeah, I think the last point I'd attach to that is a punctuation that Amanda hit on a little bit in what she was saying, but we have the sort of incentive structure is reversed by making landfilling the cheapest alternative for folks, right? It's the least desirable behavior, and it's the cheapest solution for people to pursue. So at some point, some sort of systemic change needs to happen within that structure, such that we're not making what's really the least desirable behavior the most financially attractive to folks too. So
terrific. Well, it looks like we're about running out of time, and that was a fantastic end to the topic, because we're now need to look forward in terms of capacity in New England with the regulatory structure, with NIMBY reactions, and with the growth of concerns about environmental justice communities. So, and as you said, burdening the rest of the country with our waste. Maybe that should be a topic of another one of these webinars, and what the future holds. Well, I want to thank you both very much for coming today and sharing your great wealth of knowledge. And you're getting some thumbs up in the chat. And so thank you all and for coming. And the next one is on how markets drive recycling. So after the material's through the MRF and it gets baled, where does it go? And how that really informs what we can put in our blue bins. That is on August 20th, and Chaz Miller will be our host there. So great. Thank you all, and we'll see you next time.
hi, everybody.